Hi there. So, welcome back to our Algebra 1 practice semester exam. So, if you didn't see the previous video where I had problems 1 through 6, I'll put the link there in the description so that you can go back and get those. We are definitely working through example problems so that when you take your semester exam, you've got your practice exam sitting here and you're working the problems from the test. When you work problem number 7, I want you coming back to the review here for problem number 7 so that you have a resource to help you remember, like, what did we do? How did we do that? Also, the extra credit involved. So make sure you're showing all your steps and explanations so that you can get your extra credit for doing the practice exam. So let's go ahead and get started. This video is going to take us through problems 7 through 12. I'll link the remaining videos in the description as well so that you'll have access to all of them. So for problem number 7, we are being asked to graph this inequality. I want to remind us of the form y equals mx plus b because it was going to help us to be able to graph this. Remember that b is our starting point on the y-axis, and so that point is 3 here. I'm going up on the y-axis, 1, 2, 3. And then the m tells me the slope, which in this case is -2. I want you to think of that as -2/1. So from your point on the y-axis, you're going down 2. I'm going down because it is negative. And then I'm going right 1. Do it again from that point down 2, right 1. One more time, down 2, right 1. Now I'm going to use my straight edge, which if you've seen any of my videos, you know is my handy dandy Sonic gift card. And I'm going to connect these points with a solid line. I'm doing a solid line because of that equal to underneath that inequality. So I'm going to draw myself a solid line. And then because it's an inequality, I've got to do some shading. So it is less than. So I want you to go to the y-intercept and we're going to shade less than, which would be below. I'm going to grab me a highlighter here. Feel free to use your pencil. If you have colored pencils, I kind of like highlighters. So I'm going to add this portion. And that is my solution for this problem. All right, we're going to do the same thing for number 8, but we're going to go in reverse. This time we have the shadings and we want to write inequalities for them. So we're still going to play on that y equals mx plus b form. Let's do this solid line here first. And I'm pointing out the y-intercept is at -2. So I know that b is a -2. And then count your slope from here. You're going up 1, right 1, up 1, right 1, up 1, right 1. So I put that in place of my m. And then notice that we shaded above the y-intercept. So that's a greater than, and it's a solid line, so it's an equal to. So this inequality is a y is greater than or equal to 1x minus 2. And by the way, you don't have to write the 1 unless you just want to, which is totally fine as well. Okay, let's do that dashed line then. So I'm going to point out the y-intercept is at 1, 2, 3. So I've got y, I've got a plus 3. Now let's do our slope. We're going down to 1, 2, and we're running 1. So down 2 means -2, and right 1 is a positive 1. And then notice your y-intercept, we shaded below it, so that's a less than. And it's a dashed line, so there's no equal to. So this one would be y is less than -2x plus 3. Okay, moving along with number 9 then. The amount of bacteria in a sample doubles every 12 hours if the sample initially contains 30 bacteria cells. How many is in the sample after 72 hours? Great problem here. So we want to use the formula N equals n small 0 1/2 t over h. Now, the n with the little 0 tells us the initial number of bacteria. So in this case, that's 30. Okay, now the T is your time in hours. That's 72. And the H is what we call half life. So that is, forgive me, we're not doing half life, we're doing doubling. So let's not make that a half, let's make that a double. All right. And then how long did it take us to double? That's our 12. Okay. So when I'm doubling, I use a 2 in there. If I were cutting in half, I'd use a half there. If I were tripling, I would use a triple in there. So let's go to our Desmos calculator now. I'm going to switch our view so you can see that. Still working in that same graphing calculator. By the way, I'll link it below in the description so you can use it. And I'm going to type this in, friends. I've got 30 parentheses 2 close parentheses. Now I want you to use the caret. That's shift 6, get in the exponent, and you're going to have to put a parentheses around this exponent so that you can do the division for it. And friends, notice what Desmos did for us. It found that value. It's 1,920, and that's bacteria. So just a reminder, once you can set it up with that formula, use that Desmos calculator to help you with the calculations there. I'm going to switch back so we can go back to problem number 10 next, where we're trying to put numbers in order from least to greatest, and they are in scientific notation. So what do we know about scientific notation? Well, we know that numbers that have bigger exponents are bigger. So the number that's the biggest here has to have the biggest exponent. That's got to be the one with the 3. So I know that B is the greatest. And I'm doing them backwards because we're being asked to go from least to greatest. Okay, so B is taken care of. Which one would be the next biggest? That would be the -4 power, right? So that would be D. Okay, now the A and C have the same exponent, so now we get to look at these numbers in front. The bigger the number, the bigger the value. So the A has to be the next biggest, and then finally C. And that, friends, is how I put them in order by exponents first, and then look at the actual numbers once you get down to the ones that have the same exponents. Good work on that one. We've got 2 more on this page here. For number 11, we are given an equation and we're asked to graph it. Oh, that sounds right up alley for our Desmos calculator. So I'm going to clear this one out that we used previously. I'm going to, instead of doing S of t, I'm just going to type y equals 285, open that parentheses, 1.75, close it, and then remember to use your caret, shift 6, and then you'll have to use an X there. Now, the good thing about Desmos is that you can actually use this plus or minus here to zoom in or zoom out if you need to see a bigger picture of what's going on there. So we're going to want to just draw a little bit of our graph so that we kind of get an idea of what that graph looks like. Now, one of the key points I think is right here, this -10. If you'll hold your cursor down, you can see it. It's -10 and 1 point something. So I want you to use that to kind of draw your graph. And then it gets really big. Remember, we're not after a perfect graph. We're looking for a sketch-like. And so you can do that with Desmos. If you'll use your cursor, just Click on it, and Desmos will tell you what the value is there if you need to get some points from it. Okay, we've got one more on this page, so let me switch our view back so we can finish up with number 12. This is a good one of multiply, and I don't know about you, but I'm getting the feeling I want to use the box method for this one. And you may be going, Miss May, I don't do the box. That's okay. If you do the distributive property, you and I are going to get the same answer. I'm just going to do this one with the box because I think it's fun to do different methods. Challenge myself with different methods every so often. Forgive my non-straight box. Okay, I did 3 columns because I've got 3 terms in that first parentheses. And I did 2 rows because I've got 2 terms in the second parentheses. Did you see how I listed them? Okay. If you had any minuses, you of course would use a negative with the following term. I didn't, so I didn't have to do that. And now to fill the boxes, I simply multiply. X times 4x squared gives me 4x to the third. X times 3x, 3x squared. X times 5, 5x. 4 times 4x squared, 16x squared. 4 times 3x, 12x. 4 times 5 is 20. Now, all we have to do is combine our like terms. So I see that the 4x cubed, there's no other x cubed term. So I'll write that as part of our answer. Then I see these 2x squared terms. So I'm going to add those. 16x squared plus 3x squared would give me 19x squared. Then I've got 5x and 12x. That'll give me 17x. And then I've got the 20. And that's my simplified answer because I was able to just combine like terms. I'll go ahead and link the next video for the next set of problems for the practice exam. But as always, leave me a comment if there's something else you'd like me to clarify or something I can show an example.